Cryogenic insulation blanket, commonly referred to in the LNG industry as fiberglass glass wool insulation blanket or composite insulation blanket, is an indispensable core insulating material for LNG storage tanks. The following details its applications in LNG storage tanks. Primary application areas. Cryogenic insulation blankets are primarily used in the tank walls and tank roofs of LNG storage tanks, serving as the core insulation layer between the primary or secondary barriers. Specific applications include tank wall insulation layer, installed within the annular space between the inner tank, typically made of 9% nickel steel, and the outer tank, usually pre-stressed concrete. The insulation blankets are tightly secured or fastened to the inner tank wall, forming a substantial insulation layer, often several hundred millimeters thick, that effectively blocks heat transfer from the external environment to the cryogenic LNG inside the tank. 16-C. Suspended ceiling insulation layer. For full containment tanks, the roof often requires suspended or laid insulation blankets to prevent upward heat loss and avoid frost formation on the top surface. Pipeline support areas. Special shaped insulation blankets are also used to fill and provide insulation in critical areas such as pipeline penetrations at the tank bottom. 2. Material composition and performance requirements. Primary materials, as listed in your factory's products. These materials are typically made of ultra-fine glass, wool or fiberglass, and reinforced with covering materials, for example, fiberglass cloth, to form a flexible blanket-like material. Your product. Composite cryogenic insulation, laminated blanket material, is a typical example of such applications. Key performance requirements. Extremely low thermal conductivity. This is the most critical indicator. The material must maintain excellent insulation performance even in cryogenic environments. 16-C. To ambient temperature, minimizing boil-off gas bog generation to the greatest extent. Non-combustibility. Class of fire rating. Safety is the top priority, and the material must be non-combustible. Good compression resilience and flexibility facilitates installation and filling in confined spaces while adapting to thermal expansion and contraction without creating cold bridges. Low moisture absorption resists water absorption to prevent freezing-induced degradation of insulation. Performance and material damage. Chemical stability. Does not react with LNG, ensuring long-term stability. Mechanical properties. Possesses certain tensile and tear strength to ease construction and installation.